Hi guys, how you doing? Hope all is well. What is up? Let's see here. Just want to do the 49, 57, and 65 right here. We did not get to these. Let's take a look here. El Dorado Community College has a main campus in the suburbs and a downtown campus. The amount X spent on tuition by a randomly selected student at the main campus has a mean of $732.50, a standard deviation of $103. The amount Y spent on tuition by a randomly selected student at the downtown campus has a mean of $825 and a standard deviation of $126.50. Suppose we randomly select one full-time student from each of the two campuses. Calculate and then interpret the mean of the sum, which is S equals X plus Y. All right, so remember one thing, just one key thing. Mean follows common sense, right? So right here, our mean is just going to be, in this case, if the sum equals X plus Y, our mean of this sum is just going to be right here, the mean of X, which was $732.50, and the mean of Y, which is $825. So right here. So that was once again $732.50 plus $825. And that is going to give me a grand total of $1,557.50. All right, so let's see here. Context right here. So what are we talking about right here? So we are talking in this particular case about right here. This is the mean of the sum right here. We randomly select right here one full-time student from each of the two campuses. Okay, so we're going to say right here, for many randomly selected pairs or for many randomly selected full-time pairs of students from each of the two campuses, the average sum of their tuition is $1,557.50. Let me go, I'll do the interpretation right here. We'll say, all right, so we'll start this out is for many randomly selected pairs of students from both campuses, right? And we're going to go ahead and just say right here, the average sum of their tuition is $1,557.50. Okay, something about like that. All right, so, and one thing is that instead of both, maybe it might be better to say from each campus. Right, it might make a little bit better sense than, more sense than both campuses. All right, for many randomly selected pairs of students from each campus, the average sum of their tuition is $1,557.50. So let's go on to number 57. All right, so refer to this exercise here, which is 49. Note that X and Y are independent random variables because the two students are randomly selected from each of the campuses. No problem. Okay. So it says right here, calculate and interpret the standard deviation of the sum S equals X plus Y. All right, so once again, right here, it's telling us that what? That the standard deviation looks like it's right here and right here for X. It looks like it's 103. So let me just note that. I'm sorry. And for Y, looks like it is where did it go? Right there, 126.50. All right, great. So remember, how do we figure out the standard deviation? Remember, for standard deviation, whether you're adding or subtracting right here, so the standard deviation of the sum right here, it doesn't make a difference. It's always just going to be the first standard deviation squared plus the second standard deviation squared, and you take the square root of that sum. So in that case, it's going to be right here, square root of 103 squared plus right here, this is going to be 126.50 squared, and then we square root it. So if I was doing this in a calculator right here, I would just do it exactly like this. I would just go and say what? I'm going to say, see, that's going to be second square root, and we'll just say here, say 103 squared plus right here 126.50 squared as well. Okay, and then go ahead and press enter. So we have it 163.129. That's so it's money, right? So this is going to come out to 163.13 right here, right? 163.13. And remember, this is the standard deviation of the sum of x plus y. All right, so right here, interpreting standard deviation, or just remember always standard deviation is the typical distance or typical variation from the mean. All right, so I already kind of noted this out. For a randomly selected student from each campus, the blank typically varies blank from the mean of blank, okay? So right here, we're talking about, let's put this in context right here. All right, so for a randomly selected student from each campus, we'll say right here, the sum of their tuition, typically varies about what right here? It was, once again, 163.13. From the mean of, and remember the mean was right up there, and there it is right there, 1,557.50. Okay, so for a randomly selected student from each campus, the sum of their tuitions, which is what we're talking about, right? Because remember, it is right here, S equals X plus Y. The sum of their tuitions typically varies, okay, about $163.13 from the mean of $1,557.50. All right, something about like that. So remember those key words right there. It's typically varies, all right? That's right here. That's why I say it's the typical distance from the mean. All right, the average distance from the mean. That's what we're talking about here with standard deviation. All right, so that's 57 right there. All right, let's go on to number 65. Okay. Time and motion. Let's see here. Time and motion study measures the time required for an assembly line worker to perform a repetitive task. The data show that the time X required to bring a part from a bin to its position on an automobile chassis follows a normal distribution with mean of 11 seconds, standard deviation of 2 seconds. The time Y required to attach the part to the chassis follows a normal distribution with 20 seconds, standard deviation of 4. The study finds that the time required for the two steps are independent. A, describe the distribution of the total time required for the entire operation of the positioning and attaching a randomly selected part. And B, management goal is for the entire process to take less than 30 seconds. Find the probability that this goal will be met for a randomly selected part. All right, let's do part A first, of course. Let's see here. All right, so it says describe the distribution of the total time required for the entire operation of positioning and attaching a randomly selected part right here. Okay, so no problem. So we're going to go and describe this distribution right here. So what is that going to entail? So we need right here the, which first of all, we know that the first distribution right here is a normal distribution. I'm sorry, the first distribution right there is normal, and the second distribution is normal. So we know it's a normal distribution. But we also, right here, on top of it being a normal distribution, right here, we have to excuse me, we have to describe its mean and its standard deviation. Okay, so the mean is easy. Okay, so let's do the work right here for the mean. Right here. It's going to be right here. The total time, right? So in this case right here, the total time is just going to be, the sum is just going to be right here, S. We're just going to add it up. That's going to be X plus Y. So in this case right here, it looks like the first mean is 11 of X right here. And for Y right here, that second mean is going to be 20 right there. All right, so that's mean of X plus mean of Y, which is specifically right here 11 plus 20. So right here, the total mean is going to be 31. Now, the standard deviation is a little harder right here, but let's take a look here. So what are we going to do here? Well, just like the last question right here, we said that, of course, standard deviation of the sum, that's just going to be the square root of the standard deviation of X squared plus the standard deviation of Y. So that's going to be right here. It looks like standard deviation of X is 2 and standard deviation of Y is 4. So that's going to be square root of 2 squared plus 4 squared. That'll be square root of 20. Which comes out to what right here? That's going to be, let's see, about 4.47. Okay. All right, there's the standard deviation of the sum. Okay, so it's a normal distribution with a mean of, now we're talking about right here, this is in seconds, of course, right here. So a mean of 31 seconds and a standard deviation of right here 4.47. What was it? 4.472, right? Sorry about that. 4.472 seconds. Okay, and if we had to go and, of course, give context right here, which they didn't say we did, but right here we're talking about right here bringing a part of a bin to its position of an automobile chassis right here. Requires to attach the part of the chassis. All right, so right here, the distribution of total time required for the intent. So we'll just say right here, the total time required for the operation over many times using this assembly line, we would say the total time would be about 31 seconds. Okay, and that standard deviation would just be over many times. The typical time varies about 4.472 seconds from the mean of 31. All right, so part B right here. Management goals for the entire process take less than 30 seconds. Find the probability that the goal will be met for a randomly selected part. All right, so we want the entire process to take less than 30 seconds. So that's going to be probability, that right here. Now we're talking about the sum, right? That's the entire process. So probability that the sum is going to be less than 30 seconds. Okay, so let's do it. So we're going to use that data that we just got for the sum. All right, so we said the mean was what? 31. And we have the standard deviation right there of 4.472. All right, 31 plus 4.472 is going to be 35.472. And 31 minus 4.472 is going to be, let's just do it. 26.528. All right, cool. So right here, we're going to go and see the probability that the sum is less than 30. All right, there's 30. And less than 30 is all right there. So we'll just go ahead with normal CDF. Remember that lower is negative 10,000. Upper is 30. Mean is 31. Standard D is going to be 4.472. All right, we just go and punch that in, and you end up getting right here, it's 0.4115. Something about like that. Okay, so there is a 0.4115 probability of completing this process in less than 30 seconds for a randomly selected part. Okay. So if we were to interpret that for a randomly selected part, we don't have to say over many because it's just a probability. So it's a 0.415 probability, 4115 probability of completing the process in less than 30 seconds. All right, now in this case, right here, did it say to interpret it right this? So this didn't actually say that to interpret this, so I guess that this part right here doesn't hurt to write it, but if you actually just say probability that the sum is less than 30, and you define probability that the sum equals the total time in seconds, then it's probably okay right here as long as you actually write this out and do the chart, which you should already do anyway, then you're okay. Remember, if you're using a calculator, which I think everyone is, make sure you do normal CDF. So you're probably okay right there. Okay, guys, that is about it.